Hi everyone, and welcome to our first example video for lesson 5.3, volumes by cylindrical shells. In this video, we're going to do examples 1 and 2 of lesson 5.3. So the first example is this. Find the volume of the solid obtained by rotating about the y-axis, the region bounded by y equals 2x squared minus x cubed, and y equals 0. So I've given you a picture here of the graph, and I always recommend graphing this because it will help you to determine the radius value, the height value, and everything else that you need in this equation. So I'm going to start out with my general formula. So it's the integral from a to b of 2 pi x f of x dx. Okay, and now we're doing a horizontal rotation, so I need x values here. Okay, so a and b are going to be x values, and I'm going to use 0 and 2 for those x values. And I can just calculate these points where it touches the x-axis. And the reason I'm using the x-axis for that is because it said y equals 0 here. So the y equals 0 is going to be the lower bound of my area, and this curved function is going to be my upper bound. Okay, so I'm going to have 0 to 2 here. Now the 2 pi is just a constant, so I'm going to take that and move it outside my integral. So I have 2 pi right here. Okay, and the x is the radius. Now notice that the radius here, the distance from my axis of rotation, is literally just going to be x. So whatever the x value is. So I'm going to keep that as an x. Now my function is going to be the height here. Okay, that's representing the height, the f of x. So I'm just going to keep the function as is. So 2x squared minus x cubed, and then dx. And now I just have to integrate this. So first I'm going to distribute in my x. So I have 2 pi times the integral from 0 to 2 of 2x cubed minus x to the 4th dx. Now I'll do the antiderivative of this. So this goes up by 1 on the power, and then 2 divided by 4 is 1/2. This goes up by 1 on the power, and then divide by that 5. And it's evaluated from 0 to 2, and I can't forget my 2 pi at the end here. Now, I highly recommend using your calculator to find some values for this. Or you can just do it by hand. 2 to the 4th power is 16, and 16 divided by 2 is 8. So this is going to be an 8 right there. 2 to the 5th power is 32, so this is minus 32 fifths. Okay, and now if I put 0 in, I'm just going to get 0, so this would be like minus 0 here. I'm not even going to write it because that's not going to make any difference in my calculation. Now, I can get common denominators here. 8 is 40 over 5, and 40 minus 32 is 8, and 8 times 2 is 16. So this is 16 pi over 5. And that's my final answer for that one. Okay, so let's take a look at the next example. Example 2. Okay, it says, find the volume of the solid obtained by rotating about the y-axis, the region between y equals x and y equals x squared. So again, we're going around the y-axis. So I'm looking at x values here. But this time what they've done is they've given us two functions. The red function, which I've highlighted with red, is y equals x, and the green function is y equals x squared. So let's try and plug everything into our formula. The formula was the integral from a to b of 2 pi x f of x dx. Okay, so step 1 is to pull the 2 pi out to the front. Now the integral here, I need x values because it's a rotation around the y-axis. So the x value where they cross here is 0, and the x value where they cross here is 1. So I'm going from 0 to 1. The radius value, notice we're rotating around an axis, so I just keep the radius value as just an x. Okay, the x is going to be how far we are from the x-axis. And now the height. The height is going to be the hard part here because the height of my cylinder is this distance right here, the distance from the red to the green. So I'm going to do the red function minus the green function. And we didn't need to do that in our last example because the last example only had a single function that we were using to get our area. Okay, so now all I have to do is finish this integral. So I'll distribute my x. Okay, and now I'll do the antiderivative. So go up by 1 on the power and divide by that power. Then go up by 1 on the power and divide by that power. And I'm evaluating this from 0 to 1. And I can't forget my 2 pi at the end over here. Okay, so putting in a 1, I'm going to end up with 1/3 minus 1/4. If I put in the 0, I just get 0. So this will be minus 0 there. So basically it's this with the 2 pi in front. So common denominators, this will be 4/12 and this would be 3/12. Okay, and 4 minus 3 is 1, so I would get 1/12, but don't forget I'm multiplying by 2. So that reduces to pi over 6, and that's my answer. Okay, so that's it for this video. Take a look at examples 3 and 4 on our next video.